they will keep on moving. What is the reason behind this? The reason is thermal energy. The heat energy that is present inside it, that is the reason for its movement. Okay, so what does it mean? It means that they are moving randomly. The most important word out of this is that the electrons are moving randomly. Okay, now just think about this. Okay, hear me out and think about this. If I say that there are free electrons here, okay, these are some of the free electrons here. This is, let's say, moving with a this is moving with different velocity. This is moving with a velocity u1, this is moving with u2, this is moving with u3, this is moving with u4. So why are these all velocities produced? These all velocities are produced due to thermal. It is produced, the movement of the electrons start. Well, right now also the electrons are keep on moving. The electrons are moving like this, they are moving in this way. Okay, and all of them are cancelling each other for a while, but yeah, they are moving around each other. Okay, so what you will find from here, you will find that this movement of the electron, this is referred to as drift velocity. Why drift velocity? Get the word drift. Drift means it has been dragged down, and velocity means it has been moving, right? So drift velocity means that it is talking about the movement of the electrons inside, right? So this drift velocity is first based on electron gas model. First, remember, it is based on electron gas model. Okay, now what does it state? It says that metals have a large number of free electron. Okay, almost how much? So an average idea say that it's 10 to the power 28 free electron per meter cube. Okay, this is known as free electron density. Okay, this is referred to the symbol n per unit, n which means number of electron per unit volume. Okay, got it? So what does the concept says? The concept says that a metal is usually having a very large number of free electrons inside it. Okay, in the absence of any electric field, the free electrons, move randomly due to thermal energy. As I have stated that they will keep on moving until even if nothing is there, they will keep on moving. What is the reason behind this? The reason is thermal energy. The heat energy that is present inside it, that is the reason for its movement. Okay, so what does it mean? It means that they are moving randomly. The most important word out of this is that the electrons are moving randomly. Okay, now just think about this. Okay, hear me out and think about this. If I say that there are free electrons here, okay, these are some of the free electrons here. This is, let's say, moving with a this is moving with different velocity. This is moving with a velocity u1, this is moving with u2, this is moving with u3, this is moving with u4. So why are these all velocities produced? These all velocities are produced due to thermal. These all are thermal velocity. Okay, and these are completely random. As you can see in the diagram, these are completely random. Like, what is the average speed? Well, average speed is 10 to the power 5 meter per second, around 10 to the power 5 meter per second. Oh my god, if it's 10 to the power 5 meter per second, that means around 100 kilometers per second. Yes, it's around 100 kilometers per second. So definitely these are very high speed. These are very high speed electron. But what you can find here, the average, okay, the next postulate says that the average thermal velocity of all the electrons is 0. Why it is 0? Since different electrons move in different direction. Okay, since different electron moves in different direction, the sum of all of the velocities average is equal to 0. If I just combine all of the energies here, u1 plus u3 plus un, okay, all of them will combine to give you the value of 0. Is that clear? Due to different direction, I can find that the thermal velocity sum is equal to 0. Okay, thus there is no net motion of electron in any particular direction, in any particular direction, in the absence of an electric field. Okay, I can say that the net current I is equal to 0. Got it, guys? Okay, but as soon as an external electric field, okay, as soon as an external electric field is applied, how do we apply it? By connecting to a battery. Each electron experiences electric force. Each of the electron experiences an electric force in the direction opposite to the applied field. Well, you already know these things. Okay, if I say that this is my cross section, Okay, this is my cross section. Let us say that these are my electron. So if I connect it to an external circuit like this, just assume that I am connecting it to an external circuit. This is positive terminal, this is negative terminal. It is the positive side here. This is the higher potential, this is the lower potential. So electric field will be produced, right? The electric field is produced in this direction. So if these are electron, you will find that the electron will move in the opposite direction. Okay, this is the direction of the electric field, but the force that will be tracked on the electron, this will be on opposite direction. And hear me out, okay? The direction of the field that has been produced in the electron, this is an opposite direction. So electron will try to move in this direction. Electron will try to move in this direction. But the current that has been produced here will be in the same direction to that of the electric field. The current produced will be in the same direction as that to the electric field. Got it? So what I came to know from here, that here an electric field was produced. The force that was produced here, that was equal to QE. That was equal to E into E. Okay. Got it? The force that was equal to E into E. Therefore, thus, the value of the acceleration is what? The value of the acceleration is A is equal to force by mass. This is equal to E by M. E by M. This much acceleration has been produced. Okay. Now, what will happen here? Due to this constant acceleration, of E by M with a negative sign because it is opposite direction. Okay. Velocity of electron keeps increasing in opposite direction of electric field, okay. But even this does not happen, but that doesn't happen, okay. Now what happened when the electron, like, let us say, just assume, okay, let us say that this electron was there, now the force has been produced, acceleration has been produced, okay, it is now moving in this direction. But what will happen, due to this constant acceleration, the velocity will keep on increasing, and there will be a moment after a while that no net motion is taking place. Why? Because this will happen that as soon as this electron will start moving, it will go and collide with the successive electron. Due to the collision, there will be an energy loss, there will be loss of velocity and all, due to which it will temporarily stop. So this stop go will keep on continuing, due to which you will find that no net motion is taking place by this time. Okay, let me write the explanation. As the electron accelerates, they frequently collide with positive metal ions or other electron and stop momentarily on each collision. So for a moment it stops. Well, that is so obvious that for a moment it will stop. Now due to this stop, what I can find from here, okay, just assume successive collision is taking on place. So will you be able to move at all? Just assume that you are riding your bicycle or your two-wheeler vehicle in a traffic, and you are colliding after a while. Okay, you keep on colliding after a while. So what will happen? After a moment you will stop your vehicle, that no, I will not ride it at all. In the same way, this happens to the electron as well. Okay, let us say this is one of my free ion. Just assume, okay, this is my free ion, or this is my free electron, or something like this. This is my electron here. Okay, this is my electron here. For a moment, this is my electron. For a moment, the electron collided to this, the electron collided for this. Now after a while, what has been done? The electric field has been applied in this way, the force will be produced in this way, and due to the force, it will keep on moving in this direction. So first collision took place here, took place here, second collision will took place here, took on place here. This path between two successive collision, the path between two collisions, this is known as free path. Because that is the moment where the electron is not colliding at all. So this is the time for what? This is the time for electron to relax. This is the relaxation time of the electron. And what is this? This is also the relaxation time for electron between two successive collision. Okay, I get this. Then why I'm stressing on this free path and why on this relaxation time? Because this free path will be represented by the letter lambda, and this relaxation time will be represented by the letter tau. Okay, repeating it again. The relaxation time is represented by the symbol tau, and the free path, that is represented by the letter lambda. Got it? Any doubt here? Let me mention the names. Lambda is mean free path. Because there is nothing absolute inside that. So I am talking about the mean free path. That means it is an average value. And what does tau means? Tau means average relaxation time. Got it? So yeah. What is lambda? Lambda is again a mean free path. And what is your tau? Tau is your average relaxation time. Got it, guys? Is that clear? Okay, can you let me know how much energy does the electron gains in between other two collision? This is just a matter of fact. If you want to write it down, that between two collision, energy gain of electron, energy gain of electron. What is the amount of energy that it has gained? So you will find that since the work is equal to charge into delta V, if you remember, it is equal to QE lambda. Now why this? Because delta V is equal to E dot X, and I am talking about the delta V, right? So between the two collisions, so if I am talking about E delta V, that is the potential difference here. Now since I am talking about the path in between the two collisions, what is the path in between the two collisions? That is equal to lambda. So I can say work done is equal to QE lambda. Therefore the energy stored inside this, or the energy gain inside this will be equal to QE lambda. Got it? I hope that's clear. Okay. So what I find from here, that between the two collision, electron gains the velocity for a moment, and after the collision loses it again. But still, for the next time, it will again gain energy, it will lose again after collision. So this cycle keeps on going. Okay. So what you will find from here, that in between the two collisions, they provide a small velocity to the electron, which is definitely opposite to the electric field. Okay. This velocity is known as drift velocity. This velocity that is produced due to, that is produced in between two collision, in direction opposite to the electric field, this is equal to what? This is represented by the letter Vd, which is known as drift velocity. What is the value of the drift velocity? The value of the drift velocity is around 10 to the power minus 4 meter per second. What is it? It is 10 to the power minus 4 meter per second. Can you just compare what the two different things mean here? What I told about the thermal energy, the thermal energy was around 10 to the power minus 4. The thermal energy was about 10 to the power minus 4. What is the drift velocity? Drift velocity is around 10 to the power minus 4 meter per second.
Problem is not effort. It's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.